So today we're talking about proportional relationships. First thing I'm going to do is I'm going to take this paper and I'm going to fold it where I can see the label of my foldable representing proportional relationships. We're going to look at them on tables, equations, and graphs. We're not going to worry about cutting. I want this to be able to fit into your binder still, but we're going to go section by section. So when I'm working with tables, a proportional relationship between two quantities is a relationship in which the ratio of one quantity to the other is equal. That means when I do my y number divided by my x number, it is constant. So when I'm looking at a table, my x number is always on top, my y number is on bottom, which can get a little confusing because when I'm dividing them backwards. 60 divided by 1. My y number divided by my x number is 60. I want you to pause the video for a second and I want you to set up your other three fractions. 120 over 2, your other two fractions, and see. If they all equal 60, my table is proportional. So right over here, I want you to tell me, is it proportional or not? Go ahead and pause that video now and then replay it once you're done. When I'm looking at equations, and we've kind of talked about this a little bit, a proportional relationship can be written as y equals kx, which is really just y equals mx, or if I use my calculator, ax, where k is called that constant of proportionality, which is another word for slope. The big thing with equations, they cannot have an add-on. So when I'm looking at example 2, this would be proportional. There's nothing after the x, but 6x plus 1 would not be proportional. That plus 1 is not proportional. I want you to look at those last two. If they are proportional, circle them. If they are not proportional, mark them out and tell me what's not making them proportional. Our last step is looking at graphs. The graph of a proportional relationship is always two things. It's a straight line, and it goes through the origin. The origin is that 0, 0 mark. When I look right here, this line is straight. It goes through that origin, so it is proportional. If I had to take all of this information and really simplify it down to what you need to know when things are proportional, let's make bullet points, your y divided by x is constant. For an equation, there is no add-on. It's just y equals kx, your slope, times x. And it's a straight line, and it is through the origin. So we have two examples down at the bottom. It has Dakota earns $8 an hour. I want you to create a table, an equation, and then I want you to graph it. And then on the bottom one, they give you a graph. They want you to come back, write a table, and an equation. I'll tell you on here that this is hours she worked, which needs to go on the x-axis, and the money she earns is going to go on the y-axis. And then looking at example 5, feet is on that x-axis, So I'm going to put it at the top because remember it is X and Y, and inches is going to go on the bottom. I'm going to go ahead and end this video. I want you to finish out example 4 and example 5. I'm going to be walking around and checking as you work. Let's get going.